Welcome to the Tech Deep Dive podcast, where we let our inner nerd come out and have fun getting into the weeds on all things tech. At Clarksys, we believe tech should make your life better, searching Google is a waste of time, and the right vendor is often one you haven't heard of before. Hi, I'm Max Clark, and I'm talking with Anna Claiborne, who is the co-founder and SVP of Product and Engineering for PacketFabric. Anna, thanks for joining.
Hi, Max. Thanks for having me.
For the people that don't know PacketFabric yet, or haven't listened to the other podcast with Jezebel, at a high level, how would you describe what PacketFabric is? Or actually, let me restate that. Like, what was the impetus to create PacketFabric, and then how did that influence what PacketFabric is?
So the impetus to create PacketFabric came from, a lot of it came from the cloud revolution, right, that we saw, at least that most of us in the tech world saw. So we went from this old archaic model of having to rack and stack servers, configure each and every one, or, ZTPM, and then sit there and give them all their special care and feeding, to just clicking a button or calling an API and provisioning 1,000 servers in the cloud. And, that's great. It helped really advance a lot of things technologically, helped spur this whole new revival in app development. But that same thing never happened for the network, right? And there's two sort of crucial pieces of infrastructure. There's compute and there's network at the most basic level. And I'm including storage and compute there, just two big buckets, the compute and network. And so compute leapt ahead in, these massive leaps and bounds as far as, what you could do with it, and how you could automate it, and how easy it was to provision it. And network didn't change. Provisioning a 100 gig point to point is still exactly the same as provisioning a frame relay circuit back in 1996. Absolutely nothing changed with that. And we realized that fundamentally that's a huge problem for everybody, right? Because advances in technology can only move as fast as infrastructure advances, right? And as fast as that gets easier and better, because if you're waiting months to get more bandwidth or more compute, your innovation is going to stagnate. That was the driving force behind it.
I mean, one of the big things you touched on is anybody who has ever configured or ordered a circuit from a carrier, they go through a process, right? And even if you're in a carrier neutral data center, that is a process of pain, right? I mean, I don't feel like it's so
a gauntlet, really.
A gauntlet, right? I mean, I was in a lot of forums where one of the big ones that came out was, question to the carrier: could you just automate the LOA generation process for me? If I order the circuit from you, can you just automatically send me the LOA so I can send it to, Equinix and order the cross connect without having to involve more people in the process, right?
Yep.
But PacketFabric is fundamentally more than just how do you work through this pain of provisioning these initial circuits, because, if I'm ordering an internet circuit, it's like, okay, it's a lot of pain to get it, but then it's just there. Or if I have two facilities I want to link, it's a lot of pain to get that up, but then it's just there, and we can make modifications to it. You took a pretty big next leap on this. And this is more than also just cloud. I mean, you guys, it's network as utility, it's network as code. I mean, it really is something a little different here.
Yeah. And that's, a lot of that you can sort of trace back to how we think about building our product, is that we think about it in terms of basic building blocks, right? You have ports and you have VCs. And then on top of that, what else can you build? Well, you can build point-to-point circuits, from A to B. You can build connectivity to cloud. You can do data center connectivity. And then you can do all those things from a single port, right? And if you go back to saying that, if you set up a point-to-point circuit, it's great, you're done, and you never have to think about it again. If only that was actually true, right? If only anybody never had to think about their network again after it was set up. But that rarely happens. What is the path when you need to upgrade from 10 gig to 40 gig, or from 10 gig to 100? The path is exceptionally painful. It's basically hitting the reset button on going back to, talking to telecom sales, renegotiating, going through the whole provisioning process again, the whole circuit acceptance process. You're stuck in a treadmill, going through another anywhere from 30 days to 6 months of activity to get from that 10 to 100 gigs. And we compress that down to a minute.
What I loved about PacketFabric when I first saw this announcement and you guys came out of stealth of this is what we're doing, a lot of the pain points that you get into of capacity planning, contract cycles, how much capacity do I need on what term, pricing based on term. So there's a lot of that comes into this that immediately you say, okay, you have to worry about capacity planning. What port speed do you want with us? You want a faster port? You want a slower port? You want this port? You have a port, right? You don't have to worry about capacity planning between markets. You don't have to worry about term lengths. You can get into these flexible agreements that are you don't know what you're going to do with it, and that anything that makes my life better, I'm all for it, right? Like, who wouldn't want this? Oh, wait, I don't have to think about what my 18-month plan is for capacity between these two markets. I just can change it really easily.
Mm.
I get all that, and that speaks to me a lot. How much of this though is like you build it and then see what happens? If you build it, they will come, or there's a certain amount of chicken and egg because the original idea for PacketFabric versus how people are using PacketFabric. I'd be shocked if you said you predicted all these use cases now that have come out of it.
A lot of them, yeah. I don't want to. I don't know that there's a good answer to that question because either you sound overconfident or you sound like you don't know your customer that much. But a lot of them were pretty well known even 5 years ago. Because remember, we're not that. The company is still fairly young, especially in terms of for an infrastructure company. 5 years is insanely young. And so a lot of things that existed then exist now. I think the thing that we probably didn't see being quite as popular as it is now is like the layer 3 use cases. People wanting to actually automate, setting up BGP for the cloud scenarios. Who saw cloud being a bigger thing, right? No one saw that coming clearly. But yeah, the hybrid clouds and like multi-cloud use cases have definitely become much bigger in like the last just even year or two, because I think there's this sort of people are going through a bit of a disillusionment period with public cloud because it's like there was this huge race to nobody uses servers anymore in a data center, put everything in the cloud. Everything goes in the cloud, and you have people trying to put like their AS400 database in the cloud, and then it's like, oh, that's actually a bad idea. Like that. Yeah, like that's not going to work. And also the cloud can be expensive, right? Unless you're utilizing it effectively. And so there's this mad rush to put anything and everything in there without really a consideration for fit or cost. And then now is sort of the era that I think we've been in the last couple of years where people are stepping back and saying, how do we best utilize public cloud and our own resources and make the best out of all this? And with that actually comes a lot more new communication challenges because maybe AWS has some feature set that you want to use, and Google Cloud has some feature set that you want to use, and Azure has some feature set that you want to use. Then on top of that, you want to use some Oracle, or you want to have a direct connection to Salesforce, right? So the ecosystem got much bigger. And then on top of that, you have a couple existing data centers that you have compute in, and you want to move workloads around and do all this stuff that's been promised for like years and years now, because that was the whole part of the whole potential of cloud, right? Is free the workload and, be able to shift it wherever it's most economically advantageous to run it at the time. And so people are starting to go, well, now I want this dream fulfilled, and I want to get my costs under control, and I want to run things in the appropriate places. And the little bit that everybody forgot about in there is the network, right? Because if you want ultimate flexibility in compute, you're moving all this data over the network. And if you have that super rigid piece in between that can't be changed, it can't be dynamic, you can't create new connections on the fly to where you need, that's a huge problem. Like that right there is the showstopper for that dream, because you cannot move data without the network.
I was thinking, I think it's an XKCD comic where they talk about the trough of disillusionment and like the tech adoption. So I'm cracking up over here with that. So a lot of the infrastructure companies, of course, are pushing hybrid cloud, hybrid cloud, hybrid cloud, hybrid cloud. And there are a lot of use cases that hybrid cloud is amazing. And we see them a lot with our customers. But the other one, I don't think anybody was really predicting, was this cloud to cloud, completely virtual environment of I don't have physical infrastructure anywhere. I just need AWS to talk to GCP or Azure or Oracle in your example. And I need something to actually tie all these things together for me privately, fast, and I can just click a button and make it happen. And you guys you're doing this. I mean, this is part of your, your core product. And the other thing that's I find very unique, I think, with the early story of PacketFabric was more, this idea of like layer two as a service or this network automation as a service of not per se, hey, this is a cloud connection technique. This is we want a network between point A and point B, and you want that network to be, I mean, do you guys even sell 1 gig? It's like 10 gig, 40 gig, 100 gig, X by 100 gigs, 400 gig. I mean,
we do sell 1 gig. It's actually by percentage of customer allocated ports. 10 gig is the most popular. The next most popular is 100 gig. And then after that, 40 and 1 gig have about the same percentages. And 100 gig is getting pretty close to it. It's a lot closer than I thought it would get to 10 gig demand. So that shows you where the world is going. Everything's going 100 gig.
Well, I mean, optics for an Arista for 100 gig is relatively inexpensive. I mean, you can buy a 100 gig optic for $1,500 if you're not going third party. I mean, so it's Arista, don't listen to that. But I mean, it's 100 gig finally got affordable. It feels.
Yeah, in the last year, the optic prices have plummeted, and you can get sub $1,000 pricing, at any sort of scale now for for LR4. So, and that's without even really trying, you can get better than that even. So yeah, it's very cheap, ubiquitous, affordable now.
But I mean, you're already past that point. I mean, you're at 400 gig and 600 gig and 800 gig, right?
Yep, that is where we will be going next.
This is when I feel really old, because then I have this moment of, well, when I got on the internet, I had a 56K, actually I had a 1200 baud modem, but I wasn't going to say that initially. And now you start thinking ports, like it's a 600 gig port. I mean, this is massive amount of data being shifted, but being able to gain access to that and have a dynamic pipe that you can turn up, move data, turn down, reconfigure, do something else with, and it no longer becomes a limiting factor saying, hey, I need to move stuff from from wherever they are, from 2 points, just instantly. I mean, this turns into people are doing things that would you predict? Like, would you predict that a IP transit carrier would be using you to backhaul to customers in different markets as an original use case?
No. I mean, there's definitely a fair amount of stuff we did not see coming, right? And I guess that's part of any like as a service model, right? Compute as a service, or network as a service. And so part of it is you're putting a generic framework out there and saying, hey, people, what are you going to do with this? And so there's always some surprising things. And you were mentioning before the cloud to cloud use cases, and that's definitely something that surprised me when people first started asking about that, because it's shifted. And I mean, maybe this is how old I am, but back in my day, you always had, there was always network provisioners and network engineers, and people who people who did peering, and so specialized in the network portion of it. It was this own little tight sphere of people that had deep expertise in this one area. And now there's DevOps, SRE, just straight software engineers that are just like, yeah, can I just spin up? Because they're like, their mindset and where they come from is everything's as a service. And they're asking, well, why can't I just spin up network between these two things? Like, why doesn't that work? Which is pretty obvious. When you think about it, it should work. And we're like, wow, that should work. We can do that.
I've for years now have advocated for higher bandwidth enterprises to, take some small increment of data center close to their offices and their primary locations, and do a in Metro Connect, because a 10 gig point to point circuit even 5 years ago was relatively inexpensive in a metro. And then, now you're in a data center that has, dozens or hundreds of different carriers, and you have extreme flexibility in pricing for what IP transit bandwidth you're going to acquire, or where you're going to land your MPLS circuits, or, basically the world's your oyster in terms of competition with different carriers. And, the big shift now, right? We talk about, I think PacketFabric originally, or when I was thinking about it, was, oh, I can connect my own endpoints easier, right? Or I can connect a cloud easier. But now there's also this other use case, which becomes, instead of deploying an MPLS network, I can connect to other PacketFabric customers anywhere on your environment dynamically, like instantly from any of these locations. And the data center still becomes a strategic asset for me, of get to the data center, connect to PacketFabric, have massively phenomenal port speeds, with dynamic allocation of service, And I don't need to worry about talking to a telco for MPLS because any customer that's on your fabric, I can connect to. And that's interesting as well.
Yeah, and talking about some of the old, I shouldn't say old, but some of the in the old world how it used to work. Peering used to be a highly specialized discipline, right?
Mhm.
Is figuring out who to connect to based on traffic stats, over your public IXs. Who deserves a PNI, public network interconnect, which is just a cross connect to another network to do this traffic transfer and all that now, because there's this like fundamental limitation there, especially for PNIs. If you're doing a lot of traffic to another network and you want to do it in a private, secure way, i.e., not over a public IX, that you want something that is going to be more reliable and direct. That means that you have to be in the same location as the network you want to connect to. You have to physically be in the same data center. And the great thing that we did is we eliminated that fundamental limitation. You no longer have to be in the same data center if you want to create a private direct connection to a network. So it doesn't matter. You can do that anywhere on the PacketFabric platform, and you can also still connect to public IXs over PacketFabric too, and peer with whoever you'd like to over there. But like to me, that was always one of the annoying things when I was building networks, for example, back at, I'll step all the way back to like Prolexic here just for fun. So building, the Prolexic network, which was a massive DDoS network, there was definitely like, we needed to take in a lot of traffic from a lot of different sources. And we had to peer, we had to peer wherever we could because we took in a ton of traffic over transit. And that obviously gets very expensive. And this is sort of like the first time when I encountered this, like, why can't you just get more bandwidth when you need it? Because when you're taking in, an 80 gig DDoS, which at the time was big,
Yes, yes.
that was very big. And you are, you have like, 8x10 lag to your favorite transit provider, and you can't just add another 10 gig quickly. It's very disconcerting. Takes like weeks to get that added. So anyway, we had this problem, where we needed to peer as much as possible. And, our footprint, especially when we were starting, was was pretty limited. We were only in a few data centers. And so we just couldn't get a lot of the peers that we wanted as private peers at that point. And had something like this existed, would have made it a lot easier for us.
Sure. And you still see a lot of things where it's, oh, if you want to peer with me, that's great, but you have to peer with me in 3 time zones and exchange equal traffic. And there's all these other things that come into peering that become, all these layer 8, negotiation tactics.
Yep.
My favorite is the ones when you send a peering request out and a salesperson is monitoring that inbox responds to you with like the sales, like, oh, great, like here's my sales pitch back to you. And you're like, no, this is a peering ad. And you're
Comcast.
like, oh. Oh boy, let's not get into this talk.
Yeah.
So walk us through, okay, so we've decided we're going to sign it with PacketFabric, and walk us through the process of, of what does it actually mean in terms of like, forget like, actually you have a month-to-month option, so we don't have to talk about contracts. Let's forget the whole contract point. Like from a technical standpoint, walk me through the process of what this actually looks like for somebody, and we'll pick that they're in a, they're Ashburn, Virginia, or Los Angeles, one of these major carrier hotels. So obviously you're on net and they're on net and everything works out great.
Well, you would just go to www.packetfabric.com, click on register, go through filling out, some basic stuff, technical information, address, and then you click through the MSA, click and agree, hit register. We on the back end, we just verify that the company is a real company. And the next 24 hours, you get your login, and you log into the PacketFabric portal. You would then go to order a port in the location that you are in. So say that this is 1 Wilshire, since that is very local to you. We'll go ahead and pick CoreSite 1 Wilshire. So you're like, great, I want to order a port CoreSite 1 Wilshire. You select that. The port takes about a minute to provision. You click download the LOA, and then you take that LOA and you give it to CoreSite. They run the cross connect. And then as soon as the cross connect is complete, you are connected to the PacketFabric network. And if you then say that your use case is to connect to Amazon, Google, and then also connect to your East Coast data center, you would create a connection to Amazon, which takes, again, about a minute. Pretty minor information to fill out your Amazon account ID, what VLAN you're going to use. Same thing with Google. And then you would also go and provision a port on the other side. We'll say core site again, since we're on that theme. We'll pick core site Virginia, VA1, go provision a port there. You would then follow the same process on that side, get an LOA, get the cross connect run there, and then click to create a VC from LA to Virginia. And we'll just say that that's going to be these are both 100 gig ports. You're going to do 80 gigs across the country. So about a minute later, you'd have that 80 gig connection up. And then we'll say that you have 10 gigs to Amazon and 10 gigs to Google too.
And if you're listening to this, it really actually is this easy. I mean, this is not, paraphrased in any way, shape, or form. So VCs, virtual circuits, right? That's what VCs. Okay. Also, like my brain works with associations. So I think of VCs as like, this is a VLAN tag on a .1Q trunk, and you just happen to be in between, point. Now, you're not doing that exactly on your network, but in terms of like anybody that's doing LAN networking, right? That's a good way of explaining what this actually is.
Yeah. And it does, you have a VLAN on either side that you're using. They don't have to match, of course. And so, yes, it is very much that feel is that, and on the interface itself, all we are doing is provisioning that logical interface for that VLAN. So,
and part of what you do for PacketFabric is you guys have a big software-defined network. We'll use the SDN buzzword, right? Because this thing is, right. But you have an application that's dynamically configuring and talking to, a lot now of physical devices in a lot of different locations to say, this customer needs to come up. What's my inventory at this address? Okay, I need a 10 gig port. Okay, here's the inventory for that 10 gig port. And then here's everything that has to be built now in order to connect from, LA to Amazon and East, or from LA to Virginia East, or, these sorts of things. And the explanation of what's actually happening is hiding a lot of really sophisticated things at the same time, because there's a lot of devices that have to be provisioned in order for this to work.
Yeah. There's a device on either side. I wouldn't call it like a lot of devices, but overall the network is a lot of devices, and there's some pretty, when this is starting out, I guess in my mind, it's always pretty simple because, I built the original spec for it. So nothing about it seems very complicated to me. But at scale, there's some really interesting things that happen, right? Because, the laws of large numbers start to apply, and that's where things get really interesting to me. So, yeah, we have like our in-house SDN controller, that we refer to. We wrote all of it. For anybody that's curious, this is all of our own software. We're using open source components in there, like nothing actually having to do with SDN controller, but we use a Postgres database. We use Redis. We also use RabbitMQ, and those are probably like the three major open source components that we utilize in the controller. But other than that, it's everything that we wrote in house. And I think one of the more interesting sides is our metrics collection, because we're dealing with about 500 devices now, and we collect metrics from those devices every 30 seconds to a minute. There's a little bit of variance in there depending on the device. Some of them don't like to be pulled quite that often, so we give them a little bit more time. And like pulling that amount of information, we have, it's roughly, as of a couple months ago, I didn't look today. It's going to be much larger, but as of a couple months ago, it was about a 45 terabyte database with all the stats from the network since its inception.
So please tell me you're running like a time series database in Postgres, so I could completely nerd out. Okay, see there you go.
Yeah. So we actually started off. We actually started off with HBase. So this is one of the systems.
Oh, wow.
I started. Yeah. So we started off running HBase, and let me tell you, I have a very particular set of skills that encompass being able to completely destroy an HBase cluster very effectively. I burned that thing down at least like 3 or 4 times. This is well before we were ever operational, so it wasn't a big deal. And after figuring out that running HBase and Zookeeper and all this is not for the faint of heart.
Uh-huh.
We decided to actually go with Bigtable in Google Cloud. And so we use that along with OpenTSDB for storing all the metrics. And it was super cool for a while and it worked great. And then once we started to get to really big scale, we ran into a little bit of performance problems on Bigtable, which we could have corrected by just throwing a lot more money at it. But we decided, not a big deal. We're going to move it back in-house onto time series DB, which is working great. And we've been running that for about over 6 months now. So we migrated all of our data back out of the cloud. Thankfully, we were able to do that effectively because we were directly connected to Google Cloud from our own system. That's one of the nice things, is that we were able to dog food ourselves there for transferring all that data, and it works very effectively, which is great. And so, transferred all the data back out. It's in timescale DB now, and we're running, completely our own software collection, stack, storage, everything on it now.
I wrote a building platform in the early 2000s. It was based on top of MRTG, and it was feeding data into Postgres.
Ooh.
And it really, literally, it was just a parser that was parsing. I read through the specs of the MRTG log format. And I was like, oh, I could parse this and shove this somewhere else, and it wasn't that sophisticated. But now, when I read all these things with time series databases and Postgres, I get really excited of like, man, if this existed when I was doing this, it would have made so much cooler. And then you read all these things of companies taking NetFlow data and shoving NetFlow into time series data, and just what's available now is awesome. You touched on this really briefly, but I want to walk back a second and talk about, almost every company has a redundancy requirement. Inside of a data center, you're relatively stable, cross connects. I mean, they get bumped, and inevitably somebody's working on a panel somewhere and you have a cross connect that just browns out for some, and it always is the same thing. If you have to open a ticket and they have to go and unpatch everything and patch everything back in, it miraculously just starts working again. But you offer a couple of options. There's one that's an option, right? Get a second port in a facility for redundancy, but then you also do something else that's very fun on your network that not a lot of carriers will do for you by default. And let's talk about this.
Yeah, so that's actually having redundancy by default. And it's one of those things that is always astounding to me that this is a new concept, because when you pay for something like, a 100 gig wave, and all it takes is an errant guy with a shovel to completely destroy that for, hours, days, weeks, or months, depending on the location of, where this mythical dude decided to go out and dig. It just seems like it's a really poor design, and it's a really poor investment for your money. So every service on PacketFabric is redundant by default, and we have at least 2 different carriers out of each and every data center. In the vast majority of cases, it's much more than 2. And we actually go for maximum fiber path diversity. Like when we are actually sourcing our paths, we are looking for, at what points do they cross over, right? And how much crossover is acceptable on those paths, because it happens shockingly more than you think it's ever going to happen. Fiber breaks all the time, which is just amazing. It's like, don't these guys ever call 411 before they dig? I don't know, because there's always a backhoe going through something somewhere, and if not, then it's like aerial fiber and a bird got caught in it, and and squirrels, like that is a couple of the best RFOs I've ever got, is severe squirrel infestation on aerial fiber.
I'm laughing because I know exactly. The other one that I really like the most is, somebody that was bored hunting decided to use our splice box as target practice, and shot out the splice box. And so you have,
yeah.
I mean, at this point, the ship's anchor doesn't even really seem exciting to me. What was the other one that was really terrible?
Sharks
are fun.
Sharks are good.
Train fires and tunnels. That was a good one.
Oh yeah, train fires and tunnels. Yeah, I forgot about that one. That is a very good one.
That was not fun for anybody in Philadelphia, and just in terms of, not having any internet for a week.
Yes. And there was like a big period too in New York City where there was a lot of fires and manholes for some reason. It was like 3 or 4, like one right after another.
Epidemic of fires and manholes.
Epidemic of fires and manholes, taking out fiber and destroying everything. It's one of those things that's so I'm always fascinated by undersea cable, right? And the cable lane ships. Hawiki, when they ran the new cable from Hillsborough down to Australia, Hillsborough, Oregon, down to Australia. I saw lots of pictures of that and video, and it's fascinating to me because it's so easy to forget that everything that we're doing right now, the fact that we're talking to each other over the internet ultimately comes down to this weird cable, this weird physical cable placed somewhere that all somebody has to do is chew through it. Not even a squirrel. All that has to happen is a squirrel to get bored and chew through this thing, and we are no longer talking over the internet. So much critical day-to-day activity occurs over the internet, and it rests on this very fragile underlying thing. And people have a tendency to forget that because we're so abstracted from it, but we certainly have not forgotten that, and it's a major part of our planning.
Hi, I'm Max Clark, and you're listening to the Tech Deep Dive podcast. At Clarksys, we believe tech should make your life better, searching Google is a waste of time, and the right vendor is often one you haven't heard of before. With thousands of negotiated contracts, Clarksys has helped hundreds of businesses source and implement the right tech at the right price. If you're looking for a new vendor and want to have peace of mind knowing you've made the right decision, visit us at clarksys.com to schedule an intro call. So, you say redundancy, which is the right word. Carriers talk about this in terms of protected circuits, right? So if you're thinking about the code words, if we're listening right, it's a circuit, it's protected circuits. And the cable systems, every transoceanic cable system has protection built into the cable. There's usually two paths, and on the west coast of the U.S., right, we have Hillsborough, Oregon, or Seattle. So basically, Seattle, I think, is probably the dominant one, and then it's San Luis Obispo and Redondo Beach in Southern California. But these cable systems, one cable runs across both paths that go from Seattle and they come from Southern California. So, and they're protected. The cable system's protected, but yet you can go to the cable operator, and when you buy it away from them, they don't give you protection by default. They're like, oh, sorry, you were on the southern path and it went down. Oh, you want the northern path too? Pay us more money.
Yeah, yes. And there is an economic reason behind that, right? They are in fact two different cables. There are two sets of economics at play there, and it does make sense that it costs more. It's just the thing that, especially again, as we get into this age of cloud and everything as a service and network becoming a service, you can't expect the average person buying that service to understand the depths of redundancy and why you need it and understand how cable systems work. So it just should be something that's there, that you expect the network to be up. And that's how we built our network, was to be up.
Or that the magic code word of I need to order a protected circuit, or I have an outage on this circuit and I can call up and I say, I need snap protection on this circuit. And it's you've got the magic code. It's oh, you know the code word. Okay.
Oh, okay. Yeah. You can come in the speakeasy now. And that's just a layer, our goal, and I say this in jest, but it is a good goal, is that we don't want our customers to have to talk to us. We're there if you do want to talk to us, but we don't want our customers to have to talk to us, right? They should just get the service that they expect without having to give us magic code words.
There was a big moment for me a couple years ago with PacketFabric, and one of the transit networks that I love is NTT. And they have a relatively small footprint. And part of what I love about them is they have a small footprint, right? There's not a lot of stuff. Their network becomes very efficient in how they control it and how they've built it out. And they had this little side note announcement of, hey, by the way, all of you people that have been asking us to have network in Vegas, and we're never going to build into Vegas, and you don't want to build your own waves, oh, by the way, you can get ports from PacketFabric now and come directly over to us. For me, that was a big moment. I had this oh, wow, this is really here. This isn't theoretical anymore. This is really here, because a transit vendor at that scale saying you can order 10 gigs or 100 gig circuits from PacketFabric and interconnect back with us at One Wilshire, or interconnect with us up in San Francisco, or interconnect with us wherever you want the circuit to go. And oh, by the way, PacketFabric can provide you that protection or that redundancy with it, and you can just home into ports. That's really cool.
And NTT Transit is awesome, and I'm a huge fan of NTT. They do a lot of really great automation as well on their network.
Their automation's freaky though when you get into what they're doing. It comes from the fact they've been writing it for decades, but
yeah, they do a ton of cool stuff. Huge fan of them, and it's a great use case too, because we ultimately help make them, a great transit provider, more available than they are capable of on their own, just because of the capital investment to go into every data center that somebody might want is a pretty big overhead, and the customer base in some of those is relatively small. So we provide access to that, through all of our pops. And it just like, it makes their footprint, it grows from, I can't remember what the NTT footprint size was before, but we add, 160 pops to that. So or 170 now. So it's not a non-trivial number.
I think I mean, they added Boston in the US, right? So it's 6, so it's 3, 5. So I don't know, like 8 pops, 10 pops, I want to say
That wasn't,
cities.
yeah,
It's not big.
it wasn't very many. Yeah.
So, I mean, 5 years ago when you were starting PacketFabric, I mean, this was still a relatively novel idea. There was a little bit of noise in this market, and there was this idea, and I mean, this kind of dates back to tier 2 networks that were started doing like it went from IP transit, but the margin IP transit completely evaporated, so they moved into IP transit, and then it became transport, and then there was like this idea of like remote peering that was trying to be pushed as like this, like was going to be the savior of all these networks, and that didn't really materialize. But so, the cloud interconnect and the network as a service idea, or these dynamically allocated networks, it went from conceptual to this is like really here. I mean, not only, I mean, look, data center carriers are getting into this with either in the metro or in regions, or they've partnered with companies, or they're trying to build out their own fabrics. You know, I'm it's fun to watch that happen, because it means this is a real thing, and this is not going away. Like, this is just going to become a standard for what happens here. And I've been curious for a while, like, when do we see a carrier start doing this? And I don't really think we're going to see a carrier do this, but when does a carrier actually start doing this? Because in theory, they have the last mile, which is usually the hardest component to always solve. Data centers are relatively easy, but the last mile is the tricky part. And I'm kind of curious what you think is, what you guys are looking at over the next 2 to 3 years in terms of planning and cycle coming down in the future here, because this is more than just, hey, we're going to see terabit network links. This is beyond port sizes just getting faster and faster and faster. Like, what else is kind of like the crystal ball?
So I get asked this question a lot, actually, is, when are the carriers going to jump into network as a service? And I don't even know that we'll see it in the next 3 years at all. Because here's the thing, automation's really hard. Networks are really hard, and combining the two things is really hard. Like, we have this like joke that is a running inside joke. The line in Jurassic Park, we have all the problems of a major theme park and a major zoo, which is when you're which is we are a software as a service provider, and we have a massive network. If infrastructure and automated infrastructure is hard, and that's why there's that's why you see a couple companies that absolutely dominate at it, like AWS and Google and Microsoft. That's why there's only a few of them, because these are hard problems to solve. And when you combine the fact that this is a hard problem, you combine it with carriers have never had the mindset to automate everything. Like, software is not a thing that they do. Software traditionally has never mixed well with telecommunications, pretty much ever. And then you layer on top of that the extra fact that all carriers have a ton of revenue tied to existing services, their wave services, their MPLS services, their VPLS services, all those things that are running today. Where's the incentive to do this? There's a huge knowledge gap. There's a huge hurdle in terms of difficulty, and there's a huge disincentive, from these are publicly traded companies that have a ton of revenue that is not tied to them automating a thing. So there's, they have whatever the reverse of stick and carrot is. Like,
Innovator's dilemma is I think the popular term, right?
Okay, innovator's dilemma. And that is a massive problem for them. So I just don't think it's going to happen anytime soon. And I've had these conversations with some of the folks that are working at these big carriers who are making efforts to do this automation. And some of them have done, they have implemented systems. They've built some software, but the problem is they can't roll it out for a variety of reasons. They can't roll it out because of internal process. They can't roll it out because the network is just too mess. It's just a brownfield network, which we had the advantage of starting on a greenfield and easing into a brownfield network. And that was a learning curve, and we did it. And now we're super confident that we could go into any brownfield network and flip it around. But that's 5 years of experience there. And also us having the will and drive to do it. And a carrier who just is like, oh, we're not going to do this in our brownfield network because there's too much existing revenue at stake here. We can't go and meddle with it. So you've just got barriers to entry all around.
I mean, for clarity, what you're talking about is, you started out as a Juniper platform, and then have added other, network vendors into the mix as time has passed, and that will continue to accelerate, based on just what's on market and who's doing interesting things that you actually need.
And that's the great thing about having the software translation layer that we wrote in between there, is it's just adding a module for us to add another software or to add another hardware vendor. So it's a pretty trivial effort. And it's not just that about brownfield, but it's also things like, cabling, right? We have been meticulous in keeping, all of our cabling is actually stored, in a database and is kept up to date automatically, as opposed to the vast majority of what exists out there in other companies, other carriers, anyone.
So there's a 2RU Juniper device. I forget the model number off right now, but it's 288 10 gig interfaces that'll land on this 2RU, and it's awesome, right? It has a huge fib table. It's like the holy grail of internet edge devices if you're actually a carrier and being able to do a whole table. And you're like, on the surface, this is great. And then I was talking with somebody, and they were explaining, like, how do you actually deal with 288 pairs of fiber in a cabinet at a data center wiring into one 2RU device? And, so you have a device, that's 3.5 inches tall, and you've got a bundle of cable coming into this device. It's thicker than the device is. What do you do with that? And it's such a strange problem to think about. You're like, oh man, this is such an awesome box. And you're like, wait a minute, I can't actually physically cable this thing. What does that look like?
Yeah, I mean, we have a really excellent deployment team, thankfully, that makes all this stuff look pretty, and gets the initial information into the system, right? Because it's like the point of breakdown is always the human interface in these systems, because there is no automated way to initially get that cabling information into the system other than for a human to do it. And that's where, if there's ever any errors that happen, that's where they happen. And that's the high barrier to entry there, right? Is having that human go and enter what every cable position is from the patch panel to the device. And when you think on, and sorry, going back to, because I like thinking about this telco problem, like, how would I take an existing telco and automate it, right? Because it's kind of a fun thought exercise.
Be careful, somebody might buy you if they hear this.
Is how to go back, that initial step, like how to go back and actually get all that information in, right? Because you're talking a huge existing footprint, thousands of locations, maybe more, to do that. And then the amount, the mistake rate, it's different when you're building. When we're actually building out these POPs, we're doing it at a rate that is sustainable for us to find errors. But if you're doing it on such a big scale, those errors are, you're going to have, again, large numbers coming into play. If you have a 10% mistake rate, that becomes massive.
I only know a few companies that have done these kind of migrations well. I mean, and so in Los Angeles, it's capacity, moving from one Wilshire over to 900. People hit a point and they're just at the wall and they have to move. And so watching a few companies make this transition, or a few carriers make this transition, there's only been a couple that have done a very good job at it. I mean, and CoreSite, to their credit, has done excellent with those cross connect, those hot cuts. And operationally, we're very impressive to watch this happen, because it is very difficult. I mean, to your point, I think this is the hard stuff.
Yeah.
So you had an early mover advantage, you had a greenfield advantage, and you're definitely now getting to the point where you now have a capacity and size advantage. I mean, you guys are becoming the, larger gorilla, where you have a lot of locations, you have a lot of infrastructure. It'd be very expensive for somebody to replicate from scratch what you have in place now. Your relative scale of being able to add a new POP or a new facility is relatively, as you said, trivial. It's relatively easy for you to do it at this point. and each one of those gives you incremental value to your network and to your fabric and where you're located. And it almost feels like you're approaching critical mass at some point. And again, another big moment for me was when you finally expanded into Europe, and that was, a long time coming. But watching that actually happen, I mean, that's a pretty big, going transoceanic is a big deal as well.
It is. It is. We went transatlantic and transpacific at the same time, and achieving that reach is a big deal. And again, all the problems with doing this are not where you think. At the software layer, it doesn't matter. We could add locations on Mars, the moon. We could extend out of the galaxy. To the software layer, it doesn't matter. But to the actual, building out the infrastructure, there's always just so much involved in going to new countries, right? Got to worry about setting up business entities. What does your tax structures look like? Dealing with shipping and customs. These are all the things that you encounter, and that's where the hard part comes in.
And so the big takeaway there is don't do all the hard part. Just use somebody like PacketFabric to do all the hard part for you, make your life really easy in the process. Just say, hey, I've got a web page or an API. I want a circuit from here. Click.
Yes, and that really is the beautiful thing. I mean, I wish that we had a PacketFabric that we could use to build PacketFabric on. But it'd make it a lot easier.
But at the same time, this isn't something where you're massively marking up or taking advantage of people for the flexibility of ease of time or time to market. I mean, you really are driving costs down for people at the same time as well. I mean, this is, as your costs have driven lower, you're using that as an advantage to drive your cost to your customers lower, and cost of this layer 2 network being driven down. That's going to open up doors for people to do things that were never anticipated as well. I mean, at some point it just becomes so cheap. You're like, well, why wouldn't we just do this thing?
I agree with you. I think people should. I think people should think exactly that. And that is one of the interesting things is we made this decision really early on that we were going to make all of our pricing public, because this is an as a service, and any as a service, whether network or software, you have public facing published pricing. And this is a pretty bold move in terms of telecoms. I can't think of another telecom anywhere that does this. And so it was one of those decisions that was made at the beginning that turned out to have a really broad long-term impact, because people would look at the pricing and some people were just blown away. That's it. That's all you're charging, for something that's
no catch. There's no catch. This is really the pricing. Yes.
Yeah. And we actually did face a little bit of that at first, as it looked too good to be true. Right. So you're telling me I can provision a circuit instantly and it only costs this much. It doesn't sound like, it didn't sound like reality to a lot of people. And so that was certainly something we didn't anticipate having to face, but it was interesting to say, no, we'll show you, like, it really is true. This is not hypothetical. We've built it. You can do this now. We'll show you a demo to show you that it's real, that you can actually provision this, and that is the cost.
For context, right? I mean, these are use cases where it is cheaper to provision ports on PacketFabric to cross-connect data centers within the same metro than it is to go to your local dark fiber provider and take fiber from the dark fiber. I mean, and that's, and you take a step back from that and say, well, these two buildings are massively interconnected with each other, and there's thousands of strands of fiber in the ground between them. And not only is it complicated to get access to those things, then they want 5-year contracts usually for those things, but just the price, you're like, and in some cases, so LA specifically, the market, there are some players in the market, and it's relatively inexpensive to get dark fiber between buildings, especially in the downtown area. But it's still cheaper just to go to PacketFabric and just turn it on.
Yeah. And it's cheaper in not just the respect of like what you're actually paying, but the time investment that you have to put in. To actually procure and use dark fiber it's a pretty big time investment, right? Because you're dealing with typically fiber companies are more, wholesale companies. They're selling to businesses. They're not selling to, individual consumers. So the business side is not set up to make those sales. And so you're spending, again, weeks, months chatting to salespeople doing all this overhead thing. So it's not just the actual cost, but it's the time savings that you're looking at as well, because it's pretty significant time savings and just sheer pain of doing business savings.
One of your investors has, actually, one of your investors, a very major investor, has this vision of telemedicine, but it's not telemedicine in the sense of like I'm going to talk to my doctor over a Zoom session. This was more about, can you get into a situation where you have a low latency network with high capacity and you can do things like remote surgeries? And that's a very bold vision for in terms of what actually has to happen for that network to support that. But there's a lot of infrastructure that has to go into place before that's available. I mean, I'm a lot, not just infrastructure in terms of like, cables in the ground, but infrastructure in terms of robotics that have to be at a certain sensitivity to support these things. But I mean, obviously, short term, near term PacketFabric, you talk about expanding to more POPs, more countries, more continents, more services, more clouds as they come online, more networks, right? I mean, are you starting the planning of pushing down into the last mile? I mean, is there a hit list of, let's go get into every hospital at this point? What is, how does this evolve?
So I'm really glad that you brought up the medicine, the whole entire medical field, because this is just like a hobby of mine. I love to dabble in love to dabble in medicine and genomics and biomed, and all these things are super fascinating to me. And it again, there's this thing that has happened, right? Is people have been sold this future and a lot of these cool things coming, and we don't really have the way to deliver it because the underlying infrastructure is so bad. Like, for example, there's a lot of AI out there now that does readings of MRIs and X-rays.
Mhm.
And it's already been shown, through numerous tests that AI performs way better than a human, way lower error, like much lower error percentage, much more cost effective, much quicker. Imagine if you could go in for an X-ray, and instead of having to wait a day for it to go to an actual doctor to look at it and give you a result, AI could respond to that in seconds and let you know where, if it's a break, what it is, all the information that you would need to treat. But we can't do that because the facilities where you're getting these X-rays done are, connected by 3 meg DSL off in the middle of a cornfield or something. And there's just no way to communicate back to, say, the closest data center, and, in an effective way to because images like X-rays and MRIs are actually really
Huge.
big images. Yeah,
Yeah.
they're huge images. You're sending a lot of data. So there's no way to effectively move that data back and bring this, what is like a mind-blowing advancement in terms of medicine to the consumer, all because the network sucks. And when we start to look at things like this, yeah, it's pretty obvious that, there's some places that we need to push into to help make this dream of, a better, healthier population actually happen. Because when you think that all this stuff is, all these medical advancements are being throttled by the network, it's pretty sad that we have, that infrastructure is the pinch point in this. And there's also a lot of cases like that with genetics. Like, there's massive genome databases that sit in a lot of different institutions, both private and public schools. Like University of Chicago has a big one, and
Mhm.
there's NCBI and a bunch of them out there. And sharing the information between these databases is incredibly hard because a lot of these facilities just aren't very well connected. And like so many of them have options that if you want to do a big data export, you are literally like, it says like on their websites, oh, if you need more than, X amount of data, we'll ship you a hard drive. They're still shipping hard drives in this day and age. And a lot of them also use like AWS as a FTP intermediary
Oh.
to move to move this data. And so when you think about, because what's this data is primarily used for is cancer research. And so like you could kind of, if you want to do a big hyperbole here, you could say that maybe one of the reasons why we don't have a cure for cancer is because we just can't move this data. I mean, the cure is locked out there somewhere in all these different little silos, and because they can't communicate well, we still have this problem. And those are just two examples. I mean, there's a million more of advancements that are being held back by basic infrastructure at this point.
let me take this down a notch for everybody. So one of the funniest, one of the I'll stick with funniest. So Chick-fil-A actually has a very long technical post on one of their engineering blogs. Yes, Chick-fil-A has an engineering blog. It is awesome, and
I
it talks about
really want to read
machine.
this.
It's relevant because it talks about machine vision and machine learning on how they actually predict how much food to produce in their locations. So on a real-time basis, based on trends hyper specific to that location, this application can say, hey, this is how much chicken you have in a basket ready to go, and this is your peak demand, and this is what our prediction is based on all this other data points that we have. And they have a machine vision coupled with machine learning platform that now at each physical location can say, you need to make more chicken or don't make more chicken. Really basic things. But when you look at that in scale and you say, okay, how many locations do you have across, your footprint, and what is the cost of your actual raw goods, and how many people do you have in line? And so for the average person going through a drive-through, their experience is, was it quick or was it slow? And you're like, well, if you have a positive experience because it's faster, now who would actually ever think that behind all of that, there is a computer application running with a camera
Yep.
looking at a basket of chicken, applying a machine learning model, and a data set against it. And it's like, okay, that was awesome. I never would have thought that that was a thing, right? But, when you have access to more and more data, and it's not restricted, and you can move it around, and it's like you've set it free, all these things come up that you would never think of before because somebody had some idea of like, I can make our drive-through line go faster.
Yeah, that is amazing. And I absolutely want to go read this whole blog now because that is fascinating. And it really is the perfect application of that whole promise of tomorrow. Like, well done, Chick-fil-A. And it's fun, like, so thinking back to buzzwords, it's kind of died down a little, but the buzzword of big data, right? Big data, it's all about big data. What can we find out of data, right? And data is amazing because the insights that we can gain from it can do great thing for, so many applications. But I think now we're going into the era of, big networking, because big data is great, but if nobody can access it or do anything with that data, it's not valuable. Data is only as valuable as, how you can access it and what you can do with it. And if that data is trapped, it's not very valuable.
And it has been so fun for me to chat. I actually been a big fan watching you guys develop over the last few years and coming out of stealth. I remember in the announcement, all of a sudden this group got together and everybody updated their LinkedIn posts of we're all in stealth mode, and starting to get like rumors on the of what was going on. So it's been really fun watching you guys develop. And like I said, there was a couple of really big moments for me of, this is here, and this isn't going away. And that was really, I mean, for somebody that's been provisioning telco circuits the wrong way for 20 years, having an option to do it differently is always very exciting for me. So thank you very much for your time today. It's been a pleasure.
Yeah, thank you so much for having me. This is really fun, and I can't even tell you how happy I am to learn about this Chick-fil-A blog. Like that, I feel like I've got my rest of the day planned out now. I'm going to be reading this thing.
It's excellent. You're going to love it. Thanks for joining the Tech Deep Dive podcast. At Clarksys, we believe tech should make your life better. Searching Google is a waste of time, and the right vendor is often one you haven't heard of before. We can help you buy the right tech for your business. Visit us at clarksys.com to schedule an intro call.